I want to do some practice problems using this technique of U substitution. Let's start off with this. X squared plus 3x plus 1 to the power 10 times 2x plus 3. This is clearly related to the problem that we had in the last video if you take a look at the inside part of this composition. Let's go ahead and do this exactly the same way, spotting that what we have over here is the derivative of what we have over here. So let's let u be x squared plus 3x plus 2. So du dx is again equal to 2x plus 3, and du is 2x plus 3 dx. Just as we did last time, we're going to translate this whole thing into a u to the 10th. 2x plus 3 dx is just du. And the antiderivative of u to the 10th, we can just go ahead and use the antiderivative power rule on that. That's just going to be 1 over 11 u to the 11th plus a constant. We're going to put u back in. So 1/11 x squared plus 3x plus 2 to the 11th plus a constant. Very much like what we had last time. So hopefully this methodology is making sense. Let's change this up a little bit. I know I'm erasing kind of quickly, but you can pause the video whenever you want. Let's do this one. Again, we have something of the form an outside part to an inside part, a composition. So let's let u be the inside part of the composition, in this case, x squared. So du dx is just 2x, and du will be 2x dx. Again, this became what our u is. Let's go ahead and translate into u's. E to the u, 2x dx, that's just du. We replaced what looks like a hard integral by a much easier one. The antiderivative of e to the u with respect to u is just e to the u plus a constant. Let's put u back in, e to the x squared plus a constant. Let's go ahead and do another problem that looks very similar, because it is very similar. I formerly had a 2x right there. Now I just have an x. And of course, x is not the derivative of x squared. But let's try this the same way and see how far we get. So we end up with u is equal to x squared. So du dx is equal to 2x. In other words, du is equal to 2x dx. Now, a number of people teaching this would say solve for dx and put it in. I'm going to take what's an algebraically equivalent route, and I think in my mind a little bit simpler. It'd be really nice if I had a 2x dx right here instead of an x dx. I'm going to go ahead and put that 2 in. But since I can't go around willy-nilly multiplying things by 2, if I put a 1/2 in front, then that 1/2 and that 2 cancel out. We multiply by a half and multiply by 2, you get back where you start. So now I have 1/2. Now I have my e to the u. 2x dx is still du. And so I have 1/2 e to the u. The antiderivative of e to the u is just e to the u plus a constant. And so I have 1/2 e to the x squared plus a constant. If you're wondering why I didn't multiply the 1/2 by the constant, 1/2 times a constant I don't know is just another constant I don't know. So I'm just going to abuse notation a little bit and call this C and this C exactly the same. Let's go ahead and do another problem. Let's take a look at, we'll have a variation on what we had before. How about we have x squared plus 2x plus 1 to the 100th times x plus 1. And let's try this by the same methodology. By this point, hopefully you're looking through and trying to decide what your u is. It should be the inside part of the composition. So feel free to pause this, go ahead, finish the problem if you can. I'm going to set u to be x squared plus 2x plus 1. And so du dx is equal to 2x plus 2. In other words, du equals 2x plus 2 dx. And again, I'm going to be careful to put parentheses around the 2x plus 2. Now, I don't have 2x plus 2 here. I have x plus 1. But that's practically as good because that's half of that. If I go ahead and multiply this by 2, I've got that. I'm going to go ahead and multiply it by 2. I'm going to take this and multiply it by 2 and get 2x plus 2. But since I can't go around willy-nilly multiplying things by 2, I'm going to put a 1/2 out front. Now I haven't changed anything. We're going to translate this into u's, 1/2. This is just u to the 100th. 2x plus 2 dx is just du. I've replaced what looks like a difficult antiderivative with a simple antiderivative in a different variable. So the antiderivative of u to the 100th is going to be 1 over 101 u to the 101. I don't really need that. Plus a constant. Again, I'm not going to bother multiplying my constant by 1/2 because I didn't know what this was in the first place. I still don't know what it is if I multiply by 1/2. And so 1/2 times 1 over 101 is 1 over 202. U to the 101. So u is actually x squared plus 2x plus 1 to the 101 plus a constant. Let's do another one. The antiderivative of cos 3x plus 5. What's my u? It's the inside part of the composition. 3x plus 5. So du dx is just 3. So du equals 3 dx. I'm going to go ahead and put that 3 over here. This is just u, 3 dx, but since I can't go around sorry, I skipped something. Let me move back, 3x plus 5, 3 dx, but since I can't go around willy-nilly multiplying things by 3, I'll put a 1/3 out front. So this is 1/3 cos of u, 3 dx is just du. That's an easy antiderivative, 1/3 sine of u plus a constant. In other words, 1/3 sine of 3x plus 5 plus a constant. So hopefully this method makes sense. If it does, you've got integration by substitution.